Let's start. Today we will take a look into the new part. It is about patterns, or sometimes it's called architectural styles. It depends from resources, from authors that have different statements how correctly to name it. For example, if we will take a look for such author as Kazman, he actually calls the things that today we're gonna look as patterns. If we will take a look for Neil Ford, for example, or Richards, they call it architectural styles. And basically, I would say that today we'll follow the approaches proposed by Neil Ford and Richards. So what it is generally, architectural styles. So yeah, sometimes it's called architectural patterns. This is about describing relationship of components that cover different architectural characteristics. Generally, architectural styles are quite similar to design patterns. So it means this is something that have a historical approach that can be used several times. For example, when we are talking about the layers, then basically we mean that we are talking about some pattern. We understand some aspects of structure and so on, but this actually also is architectural styles. This is one of the examples. So and what we will take a look for today, we will start from fundamental patterns, then we will try to cover layered architecture, pipeline architecture, microkernel architecture, and service-based architecture. And so the first one will be the fundamental patterns. What it is, fundamental patterns. Actually, fundamental patterns, this is the thing that historically happened that actually have place to be, but it doesn't mean that we have to follow one of the fundamental patterns. So we will take a look what kind of situation generally can be, but it means that's why you see here the space between these two, because we have to actually switch from fundamental patterns to one of their approaches. Actually, there is more architectural patterns, and we will continue with them, but this is the plan for today. So let's take a look for first one, fundamental pattern. Sometimes it's called not sometimes it calls big ball of mud. So what it is, this is something where the absence of any disturbable architectural structure. So it means the situation when the code start writing without strong view what exactly pattern or architectural style we have to follow. So it means when the developer refers to the absence of any discernible architectural structure, they start writing code, and then this code is growing, and connection between classes is growing. Normally it is anti-pattern. It was firstly defined in 1997 by Brian Foote in his article. Nowadays, what it means in modern terms, it means that it might describe a simple scripting application with event handlers wired directly to that is working directly with database calls, and there is no real structure. So it's something unstructured, and quite a lot of simple application start like something like this with unstructured, and they become unwieldy, and they continue to grow. So generally have to avoid this type of situation, because the changes that in future that you will face, it will cost quite a lot. Here is, for example, the example of why it is a ball and what it describes. In each of the corner of this ball, there is a class. There is a classes that have methods, and they are connected with other classes and methods. And as you can see, there are a lot of connection between classes and methods. So if you will need to change something in these relations, so for example, you will need to change some method, or you will need to change some body, so you have to go to another classes and methods and make changes here. But to understand where exactly you have to go, even if you will try to look in this ball, it will be hard to understand. Okay, if I will change one of this method, for example, somewhere here, then it means I have to switch from not switch, but change, sorry, functionality in all of these cases, or somewhere you can forget to change, so your logic will be inconsistent. So it will bring additional problems, and sometimes it will be quite hard to work with such projects. How the situation can be increased, so how you can face with the situation when the developers write the code without any structure, without just they cover their functionality as they can. How to build, for example, such ball. Now, there is different plugins in different idea. One of the top plugin, it calls top Code Iris. So it was possible to add this plugin to IntelliJ IDEA, and it will try to figure out all connections between classes and method that is present in your project, and present them as a ball. So you can double check your project. If you will have something like this one, for sure you are going in the wrong way. So try. I think that it's quite simple to understand that it's hard to work and make changes in such situation. Another one, but unfortunately, that one big ball anti-pattern occurs quite commonly in the real world, unfortunately. Another fundamental patterns is unitary architecture. What it is, unitary architecture. The things is changing quite fast in the world of software development. So it means that previously, for example, when the software started implemented, just 20, 30 years before, not too much, or maybe somewhere a little bit more, but in general, the software originally was only on computers, and software ran on it. So through the various modification of hardware and software evolution, they start to work previously in sometimes few years before as a single entity. Then split. There was a need to split for more capabilities, so it is growing. So what I want to say is that previously the hardware and software, it was like a single unit, and and maybe some of you know, or you are quite a young person, so maybe you don't remember the times that the computer works without the internet, and software was installed to single machine, single private computer. So When personal computers first appear, much of the commercial development focused on single machines. When the network become, then the software also changed. So this is about the things that historically happen according to the environment. And the environment is changed, so the approaches that can be applied also change, and architectural styles and patterns. It means that previously you wasn't able to talk about client server because there was no network. So nowadays the thing has changed. That's why the organization of code or software can also change, but you still can faced with old style approaches, old style software that was implemented according to situation on that time. So another one is client server. Client server, it is a fundamental style in architecture separates in technical functionality between front end and back end. Sometimes it's called two-tier or client-server architecture. Many different flavors of this architecture exist depending on area of computing capabilities. And so here is some of the examples of this approach. One of them is desktop plus database server. So it means that early personal computers architecture encouraged developers to write rich desktop application in a user interface like Windows, and separating the data into a separate database server. Another one is browse and web server. This is also like one step from a historical point where the modern web development become available and common split become web browser connected to web server. So developers got opportunity to separate the responsibilities between browser and web server, which was quite similar to desktop variant, but the client was in this case the browser. Another one, it is three-tier. So three-tier, and this approach also actually become quite popular in 90s, where three-tier architecture was proposed, and server application became quite popular. It actually was the time of when the Java and .NET was growing quite fast, and there was a lot of projects opening and outsource become growing, and there was opinion that actually a three-tier approach will be able to cover almost everything, and maybe this is quite actually this is, I think, one of the most popular approach. And even now, since now a lot of projects, a lot of situation, they still use three-tier approach that was as a basic approach, but nowadays you will see that there can be something more modern than three-tier. So one more time, what kind of tier we're talking about? So it was as a standard, a lot of developers, they mean that the database tier using the industrial database server, and it can be one of the tier, and application tier managed by application server, and front end coded in generated HTML. So yes, you can also use, for example, JavaScript on that side. So, but when we're talking about three tiers, this component was meaning that database, backend, and frontend. Now let's take a look generally. How can we divide the styles? The architecture styles can be classified into it is proposed as one of the approach to classification, but also look, you can divide it in a different ways, and it also depends. There is no like single opinion and single standard in according to this situation, but this is one of the possible way to structurize your point of view and understanding how you can generally take a look into these styles. So they can be divided into two main categories. It is monolithic and distributed. Let's start with this one. What means monolithic? Monolithic means like it is single deployment unit of all code. So you will be able to deliver your solution as a single deployment. Another one is distributed, where multiple deployment units connected through remote access protocols. Yes, actually, you can think about it in different perspectives. Here, this is one of the classification that can be applied. Um, we have to point our attention that why this classification also can be applied is that the things that is well done on one approach with a single deployment, they can bring additional issues or some problems with distributed, and vice versa. Sometimes you can face with situation when for example, one of the instance of monolithic is a layer architecture is divided as module architecture, and other like as the structures and pipeline architecture, for example, can be a part of another one. Also here you can notice that maybe additional architecture styles can be added, or this is not the full list of possible architecture styles, but let's start to look on this one. So the first one is layer architecture, and we will start from this today. This is like a grand parents of all architecture styles or patterns that is traditional one, most used. Almost all developers know about it, and we will take a look and we will start from layer architecture. There is another one is pipeline architecture, and next one is microkernel architecture. And I will tell you right now directly that it looks like microkernel architecture can be one of the most maybe not famous or popular, but one of the favorite styles or pattern if we'll compare with all others. Distributed, such as service-based architecture, event-driven architecture, space-based architecture, or pattern you can call, service-oriented architecture, and as you know, I believe microservice architecture. This is one of the possible approaches that can be applied. Distributed architecture styles have significant trade-offs. It means when you will choose one of the distributed architecture styles, maybe it looks like modern things, and you have some courses. I believe you have them, or you will have, or you already have some courses about the microservice architecture, but it's just only one of the possible approaches, and even that is now quite popular. And I can say, for example, last 5 years there was a lot of workshops, and even before that, everything you have to choose microservice approach, microservice is good, and so on and so on and so on. I have to say that there are significant disadvantages in such approaches if we will compare even with traditional layered architecture, and we will take a look for some of them right now. So it's not about just only architecture, but all of the distributed one. So keep in mind this, and when you will choose such one of the approaches, you have to understand trade-offs. So the advantages and disadvantages between each of them. There is a new term which is called fallacy. So is something, what it is? It is something that is believed or assumed to be true, but actually it is not. So, and we will apply this term to distributed approaches. If we will choose one of them, then we have to know that next statement that we believe that they will be, if we'll choose microservice, for example, architecture, then it should be fine with this, it should works. But in real life, be ready that you will face with next situations. What I'm talking about is, and for example, the first one is the network is reliable. So it means that maybe if you will have two services, let's call service A and service B, and you think that everything will be good in point of reliability. Reliability, just quickly remind you, this is one of the quality attribute or architecture characteristic that we cover, that should be covered, and it's also one of the quite important characteristic reliability of the system. And now we're talking about the network reliability. And because we're talking about the distributed, so it means there will be at least two services, and they have to communicate between each other. And we assume that, okay, we will choose, for example, let's say service-oriented or microservice architecture that rely on the network communication between services. And we assume that there will be no issues with network, but it's not true. It will not work maybe sometimes as you expected. So this assumption that the network is reliable, it is not. While networks have become more reliable over time, the fact of the matter is that network still remains generally unreliable. And this is quite significant for all distributed approaches, because all distributed approaches styles, whenever you will choose, rely on a network for communication to and from services. So you will also communicate between services. Let's assume, for example, that the service on the right side hand B, it's quite healthy, for example, but the service A on the left side cannot reach it due to the network issues that is happening. So let's say you write the system where the front end is working with the service A. It makes some order to request some order to service A, and during this processing, you have to update the profile data or something like in service B. Even if service B is okay, it's running, it's up to date, but due to the issues with the network, you are not able to reach to this service. So you will face a situation when you will not be able to successfully complete your functionality, or if you, moreover, if you will write something into database, what you will do in this case, you have to revert this data and so on. So or even if in case, for example, there is some delay on the network, then